Hi, welcome to the Shiko math step problem solving session. So today we'll continue work on the hypothesis testing problems here. And our previous video and we talked about is started to find the most powerful test here. So let's take a look here. All right, so this is what we did our previous videos here. We have a sample size is only equal to 1. And then we want to find what is the power of the most powerful test for test the hypothesis theta equal to 1 and versus theta equal to 2. And so for today's video, we're going to increase that. We're going to increase to the sample size equal to 2 for x1 and x2 from the same parent population. And for today's problem, we want to show the rejection region for the size alpha for the most powerful test that's here. You can write as the x1 times x2 greater than some k star constants here. And the k star and the alpha value have the relation. We know the k star times 1 minus natural log k star equal to the 1 minus alpha. So, okay, so let's go ahead and just get started here. And let's go to the whiteboard and take a look here. Okay, so now let's just first here. And so we know the most powerful test, just like we did before. So we have a likelihood function with the theta zeros, right, over the likelihood function versus theta ones here. And since this is the two samples right now, so we know let me try to write in here, the x1 and the x2 here will just be the theta to the square. And then we have x1, x2, the theta minus 1 here. So we know here is x1 is from 0 to 1, and the x2 is also from 0 to 1 here. Okay, so now when the theta 0, we know the non-hypothesis equal to theta is equal to 1, right? So theta 0 is equal to 1 here. So this likelihood function will become, this is 1. Then when the theta is the alternative hypothesis from our problem, we know the theta equal to 2. So when the theta equal to 2, so the likelihood function here is be the 4x1 times x2. And then we set this number less than some value of the k. So after that, then we can say that x1 times x2 is greater than 1 over 4k. So I can call that this is a k stars here. Okay? Okay, so now we want to find, okay, so here, so here, let's take a look here. And okay, so here, okay, so this is my x1 and the x2. Okay, so x1 and the x2, because in here they are from the 1 to 1s, right? So I can find the domains here, and here I can find the domains here. Oops. Okay. All right. So now I want to find, okay, so here in order to find the alphas here, right? So in order to find the alpha, I want to find the probability x1 times x2 greater than k stars here. So if you look at these domains here, the x1 times x2 greater than k star. So if you put like the value here and x1, x2, okay, so this lines here, this curve here is x1 times x2 equal to K star. And then this number, this probability really is the shaded area. So where is the shaded area? This is the shaded area I want to find. And so here, then this point here, so this point is when the x1 equal to 1 here, right? So this point is 1 and what? And 1 is a k star. And this point is here is what? This point here is a k star and a 1. Okay, okay, so now let's see here. How do I take the integration for these numbers here? So I want to find this is the shaded area. Okay, so here the first I'm going to integrate and respect to the x1. So now in here under the non-hypothesis, I know my f(x1) and x2 will just be what? Will just be ones here, right? So will just be 1 here, okay? And now let's take a look here. Right, so the joint PDF for f of x1, x2 is equal to 1 is because when under the non-hypothesis theta equal to 1. So here, right? So theta equal to 1 will just be the 1 to the square, then x1, x2, and the 1 minus 1. So that's why my f of xy is 1 here. So that's why I put here, this is 1. And first I want to integrate respect to dx1, and then I integrate to the dx2. Okay, so if I integrate from the x1 here, so basically I'm integrated from here to here, right? So kind of, so that's why I'm an integrator, right? So it's these directions, correct? So so it's x1. So if I'm integrate x1, so let's take a look and then what is my lower bound and what is my upper bound. So my lower bound here will just be the k star over x2 here, right? Because this is the curve. The curve here is x1 times x2 equal to the k star. So that's why the k dx1, the x1 is start with k star over x2. And then I integrate all the way to where? All the way to 1. Now, after I finish all the way to 1, then I'm going to integrate the y. So it's y is start from the where? The y start from the k star or equal to 1. Okay, so now this will just become a simple calculus problems, right? So this is a k star equal to 1. So the dx1 is here. So this will be x, and this is the 1, the k star over x2. I still have a dx2 here, right? So let's take a look here. Then here, this will be just the k star over 1. So you substitute the upper bound, so it's 1 minus. So 1 minus what? So 1 minus, and then you substitute, so this will be the k star x2. Okay, now I do the integration of the dx2 here. If the x2, so this will be x2 minus, right? So this is minus, this is 1 over x2, so will be natural log x2 and times k star, and my upper bound is 1 and the lower bound is k star. And I know this is a greater than, right? So it's a greater than, so this area is my critical regions, right? So it's alpha here, all right? So that's careful here. Okay, so now let's just substitute. So so substitute 1 minus k star natural log 1 and minus k star and then minus k star natural log k stars here. all right? And these numbers here, natural log 1, I know is 0. So that's what I have here is 1 minus k star. Okay, so this is the 1 minus k star plus k star natural log k star. Okay, and I know the whole thing here, this is equal to what? This is equal to alpha, right? So this is equal to alpha. So I will minus 1 both sides here. And so I will have here, okay, so that's why I will, my left-hand side will become k star. I can factor k star out. And then this would be the 1 minus natural log k star, and would be equal to the 1 minus alpha. So basically, you can just like the minus 1 both sides, and then take the negative signs, both sides here. Okay, so now that's how we got here. Okay, so let's draw our, that's how do we define the critical regions, and then, so the critical region we know is this one's here, right? So it's x1 times x2 greater than k star. And what is the k star's value? The k star's value here, this is how do we define the k star will be the k star times 1 minus natural log k star equal to 1 minus alpha. And you'll be able to solve it, using some of the graphing calculator, or, can solve what is the real value of k star. All right, that's it. And so for this problem, it's a little bit kind of get a little bit more complicated, but the main thing is the key concept of the most powerful test is still the same. So here is just testing your calculus knowledge, basically. All right, hope that you enjoyed this, and hope this is helpful. Okay, that's it. And guess we'll talk to you in our next video then. Okay, bye-bye.